Hello, my name is Bob Thorne and I'm a Senior Applications Engineer here at Radan. And today I'm going to take you through what's new in Radan 2015, the latest release of our CAD/CAM software. Now, over the past year, the Radan program has been very busy introducing new technology and functionality into this release of software. So please sit back, relax and enjoy this presentation.
Now I'm going to go through what's new in Radan 2015, but if you want to see a detailed list, there are two ways to go about it. On your DVD or in your download directory, there is a directory called Release Notes, and in that directory is an exe called releasenotes.exe. Now if you double click on that, it will display a list of all the features that are currently in Radan 2015. Now alternatively, if you've already installed the software, simply go to your help, and in the help menu go to recent enhancements, select the latest version of software, and you again will see a detailed list of all that's in Radan 2015. In fact, in the help command you can go back to all previous releases that are listed here. File browsing. Now this is a simple change, but it affects all dialog boxes where you search for files within Radan 2015. Now previously, when you opened up a search box, the files displayed would be those appropriate to the search, i.e. symbols, drawings, DXF files. What we've done with all these dialog boxes is now add the option for all files. So in effect, when you open the dialog box and select this option, any file in that directory will be displayed in the list. Multiple sessions in Radan. Now some of you may not know that in Radan you can run as many Radan sessions on a single PC as the hardware will allow. So even if you've only got one license of Radan, you can still open up multiple sessions. Now this is useful, for example, if you wanted to edit a nest in one session but then look at a part in another. Or alternatively, you might want to open up a part and copy the tooling from that part to another part, and you could do that across sessions. Now the downside of this is that sometimes we got a conflict with, for example, the machine tool data or the last used files and folder data. In Radan 2015, what we've done is we've introduced system data to each of the sessions. So each session that you open up will have its own set of system data. So you can see here on screen, in this session I've got a part with some punch tooling on it. In a second session I've got a different machine tool, a part with some laser profiling on it. In Radan 2015, this potential conflict has been removed by applying separate system data to each of the Radan sessions. Missing parts in project nesting. Now some of you may have found that after a server move or a system crash, when you open up a project nest, you get missing symbols. So what we've done in Radan 2015 is enhanced the symbol search dialog to include project nesting. So now if you open up a project and symbols are missing, then the system will automatically look in your symbol search folder to see if it can locate those symbols. We've also enhanced the thumbnail macro, so if these symbols are missing, then you can rebuild the thumbnails using the thumbnail macro for any symbols lost in a nest project. Sheet loading. Support for sheet loading has been greatly enhanced. It is now possible to configure different loader types in a machine definition, which can then be activated in the machine configuration editor. Rather than leaving it up to the post-processor to ask the user to use a sheet loader, it is possible to add order mode commands to specify the manner in which to load the sheet. Let me show you this in action. So you see here in the machine configurator editor, under the option of loader unloader, I can now select from a pull down list the manner in which I wish to load the sheet and the manner in which I wish to unload. Now, staying with sheet loading, for those of you that manually load sheets, it's now easier to choose which load pin to load against. The load pin can now be specified in the job setup dialog box. So let me just show you that in this little video here. So in order mode, I've got my nest. If I go into my job setup, you'll see here that under sheet load unload, I've got the option to select from a pull down which load pin I wish to load against. Now, for those of you that use a part picker to load the sheets, the sucker selection is now worked out by the software rather than the post processor. But this sucker selection can be overridden using the Advanced button in your job setup dialog. Part removal. In Radan CAD/CAM 2015, each part pick instruction is now validated against a number of parameters. Validation was already in place for automatic embedded part removal, but has now been extended to order mode. It is now possible to define key suckers on the picker. By definition, it is not possible to perform a pick operation on a machine without one or more combination of key suckers being activated on the metal. This is now reflected in the software. It is not possible to add a pick without suitable active suckers being available. A new system data item has been introduced to the machine definition file defining key suckers that must be turned on and over the metal when picking. Scatter. In Radan 2015 we have added a scatter option in order mode. The scatter option will be added to the subdirection command that makes the head move a specified minimum distance away from each part after cutting it, instead of moving to the next nearest part. For laser machines, the scatter option can act as heat avoidance, although it does not use our current heat avoidance data. The scatter option can also benefit punching machines. When punching large grids of holes to avoid excessive deformation of the sheet, it is beneficial to skip alternate holes. The scatter option will facilitate this style of punching. An option is added to the subdirection command, consisting of a new keyword scatter followed by two numeric arguments. And here we can see an example of that. We have the scatter command followed by the amount of movement required and then followed by the shape code. Let me explain the shape codes to you. You can see here we have a part with a rectangular bounding box surrounding it. So this is shape code 0. So if the shape code is 0, then the avoidance zone around each cut item is a rectangle, which is at least the specified distance outside the item. In other words, it is the item's bounding box expanded by the distance on all sides. Now, if the shape code is 1, then the avoidance zone around each cut item is a cruciform shape, the arms of which extend horizontally and vertically from the shape by the specified distance. Now, it makes much better sense for me to show you this. So here I've got a video showing a laser profiling machine without the scatter command enabled. So in effect, each adjacent component is being profiled. Let's run that same program but enable the scatter command. And what you will see is that alternative parts are being cut. So it is skipping at least one part. Now this is useful for heat avoidance and heat buildup in the sheet. Now, as I said, this is equally beneficial to punching machines. So here we have a component with lots of apertures in, and this is what it would look like ordered before scatter command was enabled. So literally each adjacent punch is being hit. Okay, now let's look at that same program ordered with the scatter command enabled. And on this example, I've actually used the shape code of 1. And as you can see, that will then allow me to move diagonally, but also jump 3 sets of holes. Now this is going to spread the stress in the sheet out across the sheet, helping us avoid deformation in the sheet. So that's the scatter command new in Radan 2015. Another new feature in Radan 2015 is undercut lead-ins. When cutting precision holes in a profiler machine, it is possible to leave a small pip of material at the end of the cut, even if you've used an overburn. To avoid this in Radan 2015, we have introduced undercut lead-ins. With an undercut lead-in, we remove an additional small amount of material, ensuring that no pip remains. So here on screen you can see an example of 2 plates with some tubes that have to pass through them. And here we have a precision hole that is cut to the size of the tube. Now if I zoom in, you can see that even with a lead-in, lead-out or an overburn, I've left a small pip of material. Now this will actually cause an obstruction when I try to offer my tube up to pass through this hole. To avoid that, in Radan 2015 we added something called undercut lead-ins. So as I said, a small amount of additional material is removed to ensure that this pip of material is taken away from this hole. And as you can see, once that's been removed, the tube will pass through the hole. Okay, Now let me show you how we apply undercut lead-ins to our geometry. Now you may remember in Radan 2014 we introduced manufacturing properties added to geometry. And so we're going to use that to add the requirement for an undercut lead-in to some of this geometry. Now you'll see on the right hand side, the minute we've added an undercut lead property, the side panel has been displayed, and this allows us to indicate which of those components has got undercut lead-in technology applied. Now we can select individually, or we can window around each of the shapes that require an undercut lead-in, and again we can display it using the side panel. If we wish to apply an undercut lead-in to a rectangular or polygon hole, we have to currently apply it to each of the segments of the hole. If I now auto tool those components, the ones that require an undercut lead-in, as you see, will have an undercut lead-in applied. Now, the undercut lead-in doesn't change the underlying geometry, so you see that the circle is still intact. The undercut lead-in is only applied in the machine profiling. Now if you want to remove undercut lead-ins from all of your geometry, simply go to the side panel, indicate the undercut and hit the delete button, and all the undercut manufacturing properties will be removed from that geometry. Right, let me just show you where we set this up. So in our rules and styles dialog box under lead-in, you can see here we have an undercut property, and there I'm specifying the radius and then the depth that I want that to go. Preferred tool stations. In the tool editor of Radan 2015, it is now possible to define preferred tool stations in which the chosen tool will be loaded if possible. So you can see here my tool editor dialog box, and over here you can see that I have now got this option preferred stations. So for the specified tool, I can now nominate the station numbers that I wish this tool to be loaded in if the system can actually fit it in. Now it is only preferred, so if the station is already occupied or the tool won't fit in there, then the system will load the tool into another location. But wherever possible, it will always look at your preferred tool station locations. Tool station types. A machine configuration file can now contain more details about specific tool stations. It is possible to configure stations as specialized forming, tapping and shearing stations. Each tool can then be set to be used in a specialized station only. This further reduces the need to use standard tool loadings. So you can see here that I've got a specialized station, and then I've got the option to say must use. So a particular forming or tapping tool will be only placed in the specialized station. Auto step and repeat. Now this is a new feature to Radan 2015. Now for those of you who've got machine tools with limited memory, you've always had the ability to create step and repeats to reduce the size of the programs. But that was a manual process. In Radan 2015, in the Auto Tool dialog box, we now have the option to automatically convert punch blows to step and repeats. So you can see here that I can specify the minimum number off, the maximum number and the pitch that I want to use. So let me show you that in action. So here we have a component with lots of apertures in, and I'm just going to use a standard auto tool to tool this component. Now if I go to the delete box, you'll see that if I hover over each punch blow is in actual fact a separate punch blow. Now this would have the effect of creating quite a large program for my punching machine. Right, if I now remove that tooling, and in my Auto Tool dialog box I go to the option Step and Repeats. By selecting the tick box here, I can automatically convert individual punch blows to step and repeats using the data I've specified in these three boxes here. If I now go to the delete option, you can see that each line of punch blows is in actual fact a step and repeat. Now this will have the effect of dramatically reducing the size of the program that I send to my punching machine. So that's automatic step and repeats in Radan 2015. Rectangular nester. Here at Radan we are always striving to improve the nesting algorithms within our software. So you will see in every release of software there is some improvements or modifications to the nester. In Radan 2015 we have added some major improvements to the rectangular nester. We have now given the user much more control over the nesting times, the program reduction, nesting in apertures, and the inclusion of tooling in the part shape. Now this is specifically for the rectangular nester. Nest optimization. In Radan 2015, in the Nesting Options tab under Part Placement, we have added 5 settings which gives the user more control over the focus of the nester. The aim of each of these settings is to get the nester to optimize for a particular scenario. Preferred maximum utilization. This option tells the nester to optimize material utilization. Of all the different arrangements of parts that the nester considers, it will choose the one that has the highest utilization figure. If it finds several different nests that have equal good utilization, it will choose the one that packs the parts best in the primary direction to allow an offcut at the other end of the sheet. Preferred maximum common cutting. If you are nesting some parts for common line cutting, this option tells the nester to optimize the amount of common cutting in the nest. The nester will try to nest those parts next to each other, and it will prefer a nest with more common cutting over a nest that has a better utilization or one with a better offcut. Prefer one offcut even if narrow. This option tells the nester that you want parts to be packed tightly in the primary direction, so as to leave spare space next to one edge of the sheet, even if this is very small. This is to facilitate making a rectangular remnant. The utilization that the nester achieves may be lower on average because the nester will not try certain ways of arranging parts. On the other hand, it may increase the amount of material that you can reuse. Prefer 2 offcuts even if narrow. This is similar to the previous option, except it tells the nester that you would like to be able to make 2 or more rectangular remnants from an unused area of sheet. Instead of minimizing the length of the nest, it minimizes the area of the nest bounding rectangle. Prefer largest parts in direction 1. This tells the nester that you want larger parts to be nested first in the primary packing direction, to ensure that those parts are nested close to a particular edge of the sheet. Smaller parts will be nested afterwards in the remaining spaces, so that mainly they will be placed further away from that edge. For example, if the primary direction is towards the clamped edge, the nester will place larger parts next to the clamps. Utilization will be lower on average, but this option can help to make the sheet stable in the machine tool while parts are being cut and removed. 3D file importing. In Radan 2015 we have made further improvements to how we import and export 3D models of various file types. we've extended the range of file types that we can extract material from. This table below just simply shows what file types we can bring in, what versions of those file types, and you can see right at the end there, the X indicates that we can extract material from these file types. Equally with exporting, we can export material with certain file types. Now with two file types in particular, Inventor and SolidWorks files, we have a choice as to how we import the files. We can import them via solid link, but we also have a backup method of importing them using the native file format. In Radan 2015, the importer will automatically choose the method to import the files which gives the best result in terms of imported data. You can see here I've highlighted the two file types that have this alternative method of importation. Now, if you've imported files and you know that the alternative works best, what you can do with your File Import Options dialog box is tick this box to always use the alternative method to import your files. Bend Table Editor. The bend parameters used by Radan 3D to unfold parts can now be edited using a new bend table editor. This editor can be called from the Developments dialog box using the Edit button. This image shows the new bend parameter editor. Here you can see we can input our radius, our bend relief and our hem radius. We have the radius is listed down here with our allowance values associated to them, and this graph displays these values in a visual way. Let me go and show you that in action. So as I said, to access the new bend table editor, we simply go into the developments option, and in the developments dialog under edit we can access the new bend parameter editor. And it's a simple case of simply dragging this graph to edit the values in the table, making it very easy and quick to edit your bend parameters. You can, if you wish, click into this list and manually type the values that you require. Another advantage of the new bend parameter editor is the introduction of material aliases. If you read in a file into Radan 3D and it has a material of MS instead of mild steel, what we can do is we can nominate this in the material aliases so it will be correctly unfolded using your bend parameters. So you can see here under my mild steel I have an aliases option. If I click on that, I've got some aliases that I've defined that will be correctly unfolded using my mild steel parameters. This will ensure that I get the correct developed blank from my parts. Fold up from flat. It is now even easier to fold up a flat blank into a 3D model. In Radan 2015 it is now possible to add manufacturing properties to lines on a flat blank. These properties will be read by the fold up from flat option, automatically creating a 3D model from your flat blank. In this image here you can see the Edit Bend Properties dialog. By simply selecting these tick boxes and feeding in some information, we can assign this information to lines in our flat blank. Okay, let me show you how this works. I'm going to go in and draw a very simple flat blank using some rectangles. Just going to trim out the lines I don't need. And now I'm going to draw in some bend lines. Now previously when we were folding up from flat we had to ensure that we had the correct pen number and the correct line style. In Radan 2015 we don't need to do this, so what I can do now is add some manufacturing information to those bend lines. So if I go into Edit Properties, Edit Bend Properties, this will call up the dialog box and I will be able to input my bend information. So in this case my bend angle, my bend radius. By selecting the lines, instantly the right hand panel appears showing that I've got manufacturing properties assigned to some of the geometry in this part. Once I've assigned all of my bend parameters, just check that I've got the right lines assigned, I can then go off and fold up from flat. So I go to my fold up from flat icon. This will now read the blank and interpret the bend information on those lines. And I can fold up my flat blank into a 3D model. And there is my 3D model folded up from my flat blank. Now for those of you that have fold up from flat templates, don't worry, they will still work. So you can still use the old method of assigning line styles and pen numbers, but hopefully you'll see this is a very easy and quick way to fold up from a flat blank. Camera modes. When in Radan 3D, you will notice a new icon, the camera mode icon. This allows the users to switch between two available camera modes. So when the icon is not selected, you are in object mode, and this replicates the user holding the model in their hand and spinning it around. When the icon is selected, you are in fly through mode, and in this mode the user is able to fly through the model. Here you can see an image of the Radan 3D menu, and I'm just highlighting the new icon, the camera mode icon. Right, let me demonstrate how this works. So here we are in 3D with the 3D model. Again, I'm just showing you the camera mode icon. Now, with that icon not depressed, I can spin the model, but it's like it's spinning in my hand. Now this works equally well with a space mouse or using the keyboard and mouse. If I now go up to my menu and actually select the camera mode icon, this puts me into fly through mode. So with this selected, I can now fly through the model as well as spin it around. So that was camera modes in Radan 3D. That's a new feature in Radan 2015. That brings me to the end of my presentation. I'd just like to thank you for taking the time to watch. I very much hope you enjoyed your Radan 2015. If you haven't currently got it, remember you can actually download it from the Radan portal. You can, if you wish, request a DVD and that will be sent to you. And if you wish, you can also follow us on Twitter at Vero Software.